All right, so this is the intro to 3x3 systems and augmented matrices. So first we have a linear equation in 3 variables. X, Y, and Z is an equation of the form AX plus BY plus CZ is equal to D, where A, B, and C are not all 0. Okay, and one thing I want to point out about this form right here, when you have AX plus BY plus CZ is equal to D, that is called standard form. The following is an example of a system of 3 linear equations. In 3 variables. So right here, 3x plus 4y minus 8z equals -3. That's the first equation, equation 2, and equation 3. And you'll notice once again, that it is in standard form because all the x's, all the y's, all the z's, and all the constants are set up in that order. So for here, we have that a solution of such a system is an ordered triple XYZ, whose coordinates make each equation true. So before, when we just had AX plus BY equals C and DX plus EY equals F, we only had X and Y, and it was an ordered pair. Here, since we have X, Y, and Z, it's called an ordered triple. Okay, so since there's 3 planes intersecting, so therefore we are now in 3-dimensional space. So this is 3D. So you notice it's planes intersecting as opposed to lines. So it says to determine the number of solutions of the system as shown in the diagrams below. So here we have 3 planes intersecting, and you can see that they all intersect at one point. Since they intersect at one point, we call that one solution. And that would be written as XYZ. So 1 point means there is just one solution. Now here you're going to notice that all 3 planes, they intersect at a line. But one line is different because hopefully you recall from geometry that a line is made up of infinitely many points. So that means they're intersecting at infinitely many spots. It's so many that we call this answer infinitely many solutions. I like to abbreviate it as IMS, and it means infinitely many solutions. Now the last one, this is going to be our no solution. And the reason why it's no solution, because since we have 3 planes, all 3 planes must intersect. Here, I can see that 2 planes intersect at this line, 2 planes intersect at this line, and 2 planes intersect here, but never at any point or line do they all 3 planes intersect. And the rest of these you can see, so this is one plane on top of another, they do not all intersect. We have a plane being, not really bisected, but being hit by 2 other planes, but never all 3 planes in one spot. So that would be a no solution. I also abbreviate that as NS. Okay, now we're going to take those 3x3 systems, and we are going to now convert them into what we call matrices. So first off, a matrix is a rectangular arrangement of numbers. The dimensions of a matrix with m rows by n columns are, it's read as m by n. So it's an m by n matrix. So the dimensions of matrix A, which is right here, are 2 by 3. And the reason why it's 2 by 3 is because there are, remember, m is the rows, so there's 2 rows. So we have 1 row, 2 rows by 3 columns, and there's 1, 2, 3 columns. So 2 rows, 3 columns. So we'll put rows right here and columns up here. That way so you understand. So 2 rows by 3 columns. The numbers in the matrix are called its elements. So the number 5 is the element of the first row, third column. All right, lastly, we're going to move on to a matrix derived from a system of linear equations, each written in standard form, with the constant term on the right is the augmented matrix of the system. So if you recall earlier, in standard form with three variable, it was ax plus cy plus by plus cz is equal to d. So x, y, z, and then the constant on the right side. So for example, the system below can be represented by the given augmented matrix. So the first thing we're going to notice is make sure it's in standard form. We have x's, y's, z's, and constants. Okay? So I'm going to draw some bracket right here. And now, when I'm writing my augmented matrix, I only use the coefficients in front of the variables. So I'm going to start with x. X has a 5 in front. Y has a 3 in front. Z has a -2. And then my constant is 1. And then I go to the second row. X has a coefficient of 1. Y has a coefficient of 2. Z has a coefficient of 3. And the constant is -1. So notice they're in standard form. They're all x, y, z. And then we have 3x, so that's a 3. -4y, -4. Z has a 1 in front, and a 10. And now here you may see a line or you may see a dash just to separate the coefficients from the constants. I like to use a dash or a solid line. It's really up to you. So that separates them there. Last, we need to talk about the dimensions of the augmented matrix. So in this case, how many rows do we have? We have 1, 2, 3 rows. By how many columns? 1, 2, 3, 4 columns. So this would be considered a 3 by 4 augmented matrix because it has 3 rows by 4 columns. Now, another important thing it says, before you write an augmented matrix, make sure each equation in the system is written in standard form. Include zeros for the coefficients of any missing variables. So let me give you an example of that really quickly here. So I've only written one, but if I was doing my augmented matrix, so I have x is first, but I have no y value. So if there's no y value, I put a 0. The z has a 3, and then my constant is 1. And then whatever the rest of the problem would be, I would do it like that. So notice I put a 0 because the y was missing. So make sure x, y, and z are on the same side, set equal to a constant.